Hi everyone and welcome to today's lecture where we're going to talk about cloud computing and most importantly how to do it securely. So even though cloud computing is not something new, it is rapidly evolving technology that is really hard to define and it usually exceeds beyond the traditional client server setup because when doing cloud computing we want scalable on-demand services. It allows better hardware utilization, lower costs, and very quick responsiveness by using virtual services. And some of those you might heard about are the virtual machines that we can use for example, Linux or Windows. So the cloud solutions can really be hosted on-site or off-site. They also rely in various proven technologies such as virtualization and service-oriented architectures. So here on the figure you can see a chart with different cloud computing models. So on the left side you can see the cloud characteristics, then the different cloud service models that we're going to talk about, such as infrastructure as a service, platform as a service, and the most popular, software as a service. And finally, the cloud deployment modes. We're going to talk about those in this lecture. Now, one very important thing to mention before continuing is that this lecture is going to be of two parts. So, firstly, we're going to cover the theory or how cloud computing is designed, and after that we're going to build a simple cloud server using Python. So if you're interested in learning how to build your own cloud computing server, please stay until the end of the lecture. Okay, so traditional data centers client server model with three-tier architecture, where each server had a specific purpose and static IP addresses. They're managed to processes that are manual and spanning three protocols to avoid network loops. So today, the advancements in virtualization, distribution computing, and the high-speed internet transform those data centers to more dynamic environment, which can provide on-demand, elastic, and fully managed cloud services. Elastic means that you are able dynamically to allocate resources between different services. So those modern data centers allow users to access as much or as little as their service needs in order to be managed and processed. Alright, so next, let's look at the different cloud computing service models. So as we mentioned earlier, those are infrastructure as a service, platform as a service, software as a service, and also we're going to talk about the software as a service features. So first of all, the infrastructure as a service gives customers control over the virtual services and resources. This is like a storage processing. Those resources are given via web-based API. However, in this case, the customers do not manage the physical hardware behind the services, so they cannot customize how much memory or hard drive they want to use. Then in platform as a service, we get software and development tools that are located on the provider's infrastructure. They are also provided by web-based API. The platform as a service allows us to build application on a specific web platform without the need to download anything, but still we cannot manage the underlying physical hardware. And finally, the most popular service probably these days, this is the software as a service. The software as a service allows customers to use software hosted by third-party provider that eliminates the need for us to get upfront license or fees just because this third-party provider is already licensed. So once we build a SaaS application, our customers can access this application over the web. They can purchase our services from that specific application, so we will not need to host any servers. We can build applications, for example, using Python, Java, Node.js, and so on, deploy those services, and then allow people to use our software from the web. So as we said, SaaS is probably one of the most popular models, and this is for a good reason. The first thing is that SaaS has very good scalability. It can handle growing amounts of work in a graceful manner. We can create an application and we can allow multiple users to use that application while scaling the resources from the third-party server that we use. We can literally service hundreds of companies at the same time. So we talked about the cloud computing service model, so now let's talk about the cloud computing deployment models. And there are a few of those as well. The main one are really three of those, and they also referred as cloud types. So public clouds are available to anyone over the internet. Users can rent resources as needed without buying their own infrastructure. The private clouds are hosted by organization and can only be accessible by the members of that organization. They offer more security since they use the organization's own resources and are protected by their security measures. So every company can have different security measures. So the levels of security for each of those private clouds might be different depending on the business. And finally, we can have hybrid clouds, which really combine the features of both public and private clouds and use resources from both. Now, the next question you might have is what is virtualization and how is it implemented in cloud computing? So, virtualization involves creating virtual versions of software or hardware that can function like the real thing, but aren't actually physically present. In computing, virtualization is used to create virtual operating systems and hardware resources like services and storage devices. This process boosts the performance by dividing the physical resources into multiple virtual resources, which means that, for example, from one physical server, we can create multiple virtual computers that different users can use. Applications and tasks can easily move between the physical and the virtual machines that will really enhance the efficiency. So you can see that virtualization in computing, especially in cloud computing, plays a very key role. It allows applications from different users to run on separate virtual machines. That will ensure their isolation from each other and security as well. So the virtual computer system can and must simulate the real existing computer system, which means that all programs that normally run on the real system should be also able to run on the virtual system, and to run they should spend identical efforts. So in the environment of virtual machines, we need a tool called Hypervisor that will control all of the sandboxes or all of the virtual machines. So depending on the underlying architecture of the hypervisor, we can either have a true separation between virtual machines or not. And there are actually two types of hypervisors, and you can see the figure of the first one right here on this slide. So the hypervisors run directly on the host hardware to control the hardware and to manage the operating systems. So the figure here represents the classic implementation of a virtual machine architecture. There are actually many modern services that are based on this architecture, such as the VMware ESX or Microsoft Hyper-V. So in this hypervisor, all virtual machines are serviced by the hypervisor and are running on guest operating system. As you can see, the hypervisor runs as part of the operating system, which is the native operating system, not the operating system of each individual machine. And the hypervisor runs in the same level as the file system, the device drivers, the network stack, the kernel even, and so on. Now, the hypervisor of type 2, which is called hosted hypervisor, and here the difference is that the hypervisor runs above the kernel and the underlying operating system. So when the hypervisor is distinct second software level, the guest operating systems run at the third level above the hardware, as you can see. In that case, the host operating system has direct access to the server hardware, such as the whole CPU, memory, input-output devices, and so on. So in that case, the hypervisor creates a virtual machine environment and coordinates the calls to the CPU, memory, disk, network, and other resources through the host operating system. So modern hypervisors that are built into this model are the KVM and the very popular those days VirtualBox. So now once we know the main architecture, we should talk about the vulnerabilities of this architecture and of the hypervisor. Since 2006, research have shown that malware like the virtual machine-based rootkits can install hypervisor beneath the existing operating system, making them hard to detect. There are possibilities to log in to specific virtual machine and escape to other virtual machines that the user is not authorized to use. For example, in the Type 1 hypervisors, which have and give us full access to the system resources, there will have more vulnerabilities because breaching into one virtual machine can breach into the whole cloud system. In contrast, the Type 2 hypervisors with microkernel architecture can better isolate the virtual machines, and this would definitely reduce risk. We usually have load balancer for every hypervisor to dynamically allocate the traffic between the different machines. In that situation, the load balancers play a very key role to ensure fair distribution of the load along the virtual machines, especially during the high traffic. So how this works? Normally, the load balancer listens to all the traffic of the internal network and distributes the incoming traffic across the cloud infrastructure. It also automatically scales its request handling capacity based on the incoming application traffic. Load balancer is also a key target for attackers because it handles all traffic on the cloud's internal network. So if the load balancer is compromised, attackers could interact with the secure traffic or redirect it to some insecure services, leading to further attacks. Additionally, it is valuable to the denying of the service attacks that can disrupt the whole cloud activities, and we were talking about denial of services attacks in our previous lectures. So yes, they can also be implemented on the load balancer when using clouds. In order to secure the load balancer, it should always be properly configured and monitored. The access to the load balancer should always be restricted to specific administrative network that will limit who can manage the load balancer. So in cloud computing, the main participants are the cloud provider, the customer, which is a data owner, and the user, who may not own the data necessarily. Sometimes the customer and the user can be the same people. So both the provider and the customer delegate responsibilities to their representatives. So a very key security concern arises from weak access controls. To address this, both the cloud-based and the local services need robust access control policies that include password management and so on. So some of the major cloud service providers, you might know some of them already, are AWS, which is owned by Amazon, Microsoft Azure, and Rackspace. And all of them strongly invest in strong access control systems to ensure high security of their clouds. Now let's look at how we can implement a real cloud using Python. I will use a basic Python syntax without importing any libraries, so you can see how really easy it is. Okay, so in our design we want to be able to do a few things. Okay, so we want to be able to upload file to our cloud. Then we also want to be able to download file to our cloud. We want to be able to register a user, and we want to be able to also log in to our cloud account. Now, once we create the cloud, we will also need to be able to interact with it, just like interacting with your computer from the terminal. We want to be able to do exactly the same thing with our cloud. So to implement all of those features, what we need to do is to create a new class, and then we're going to add the features as methods to this class. So let's create a class, and I will call it cloud storage. Okay, And here, firstly, I'll create a function called init, and this init function will hold all the cloud instances that we create, and it will construct each individual instance. Okay, so we want to make sure that when we create a cloud, we have immediately also created two dictionaries with the cloud. So I write here self dot storage will be equal to an empty dictionary, and I also do self dot user or users will also be an empty dictionary. So here we're going to store the files, and we're going to store then the users for the particular cloud. Now, firstly, I'm going to create a function that will be called encrypt, and we're going to pass all the data through this function in order to encrypt it. So as you can see here in the encrypt function, we have the content and we have the key. So the key is always going to be equal to 3 for this example, and every content that we pass through this function is going to get encrypted, and then it will be returned. So we'll make sure that all the content going on our cloud is firstly encrypted, and you will see how we're going to use the function later on. Then obviously, if we have the encrypted function, we also want to get the decrypt function. Okay, and here is the decrypt function, which will do exactly the opposite thing. As you can see here, as an encryption and decryption algorithm, I am applying some custom algorithm. Okay, so for every character in our content, I'm going to pass it through this equation in order to encrypt it, and then respectively decrypt it. This is obviously not as secure as using built-in algorithm for encryption and decryption, but it is sufficient for our cloud and for this example. Okay, perfect. So now the next thing we want to implement is a function that will be called upload file. Okay, and here I will again write self, then file name, content, and user. Okay, so bear in mind that the way we're going to design our cloud, every user will have specific privileges. So they will be able to either read, write, and we want to make sure that every user has specific privileges when they log into their account. Okay, so when we want to upload file, we want to make sure that the user has right privileges. So I will do if user in self.users. So first we will check if the user is in our users list, and self.users user. So if the specific user, I will do .get, and here I will check if the user have right privileges. Okay, so I will check if the right, then this would mean that the user is able to upload file. So let's now write encrypted content. Okay, and firstly, before sending the file to our cloud, we want to make sure that this file is encrypted. So I will do self.encrypt, and then I will pass the content. So once we do that, the content will go through this algorithm here that is called encrypt, and this is what we're actually going to save inside the cloud. So if somebody breaks into our cloud and gets our content, they will not understand what it means since it is encrypted. After that, let's do self.storage file name. Okay, so we're gonna create a new element into our storage dictionary with a key, the name of the file, and then the content is going to be the encrypted content. So the idea is that the user will specify a file name and what content is inside this file name, and then we're gonna encrypt the content and we're gonna save it here in our storage under the file name. Okay, and once this is done, we want to return file and then the name of the file, so file name, upload it, successfully. Okay, and in case that the if statement don't pass, then we want to say to the users that the file was not uploaded. Okay, so I'm going to do exactly this. So then write else user does not have write permissions. Okay, perfect. Now, since we can upload file, we also want to make sure that we can download file. So let's create a function that will be called to download file. Okay, and here we need the file name and the user. So if we have the user, we can see whether this user can read this file, and when we have the file name, we can actually take the file from our storage dictionary. Okay, so first let's check if the user has the right privileges. So I will do if user in self.users and self.users. So firstly we check that the user is in our user list, and then we'll check if the specific user has read permissions. So I will do dot get read equal to false. Okay, so if this is the case, then we should be able to return the file name and the content of this file. Okay, so now once we verify the user, now let's check if the file is in our storage. So if file name in self.storage, so if the file is in the storage, then we're going to get the file. So I'll write encrypted content, because don't forget we store the files as encrypted text. So I will do self.storage and then file name. Okay, so we're gonna get the content of the file, which is encrypted. Now we have to decrypt it. So I will do content equal to self dot, and now you can guess which function I'm going to use. I'm going to use the decrypt function. So self dot decrypt, and then we're gonna pass the encrypted content. Okay, so now we decrypt the file name, and now we want to display to the user. So we'll do return f file, then I will show the file name. Okay, and then I will do content, and then I will display the content of the file that we uploaded. Okay, so if this if statement breaks, obviously we want to say that we don't have the file in our cloud, and if the other else statement breaks, we want to say that, so if the other if statement breaks where we authenticate the user, we want to say that the user doesn't have the right permissions to access those files. Okay, so now we need to add two more functions, and one of them is going to be to create a new user, and the other one is to list all the files. So let's first create a function that will list all the files. So I will do list files and then self comma user. Okay, and after that let's do if user in self dot users and self dot users user. So we want to check here if the user again has read privileges, meaning that they can read everything in our cloud. Okay, then here we're simply going to return all the users on our system. Actually, in this case, not all the users, but all the files that this user manages, right? So let's do return files. Okay, and here I will simply show the storage dictionary. Okay, so you can simply show all the files by writing like this, comma dot join, okay, self dot storage dot keys. Okay, so every key in our storage, which means every file name located in the storage, will be presented separated by comma. Okay, and this is how we're going to list the files. And obviously, if the user is not authenticated to see all the files, then we're going to return that the user don't have the right permissions. Okay, and finally I'll create one last function that will be called add user, because obviously we want to be able to add users to our cloud. So let's do user name, permissions. Okay, and let's add a user. So let's do self dot users username permissions. Okay, so we will add a new element into our dictionary that will has a key, the username, and as a value it will have all the permissions that this particular user has. Okay, and finally let's print something. Actually, let's return something that will show that the user is added with the following permissions. Okay, perfect. Okay, now once this is done, let's create our main program. So I would def main, and here I will create a new cloud storage called cloud, and I want one user that will be called admin. In the user, as you can see, we have a read and write privileges. Then I also create a variable that the name of the current user is going to be admin, but of course we will be able to add more users if we want to. So now our cloud is created. Now the next thing I want to do is to be able in real time to ask the user to write commands to our cloud. So I want to prompt the users to be able to add users, upload files, list files, download files, and so on. So we can do that by creating a while loop. Okay, so we'll say while true, and here I'm just going to display the name of the user, and with this string I will show that we're currently in the cloud, so we'll always know which user is currently logged in. And if we click enter, so there's no command, we'll just continue and keep displaying this command right here. Okay, so the feeling will be like we're exactly writing in a terminal. Okay, so wherever the user writes here in this input, it will be assigned to the command. So now we'll have a few commands which will be to exit, to add users, to add file, to read files, and so on. Okay, so we need to make sure that this command is the one we're looking for, and after that we want to enable the user to do certain actions based on the command. So first of all, I'll put the command with lowercase just to ensure that the commands are matching. And after that I will start adding the options. Okay, so let's add the first option. So I will do if action is equal to exit. Obviously we want to exit our cloud, so I write here print exiting the cloud. Okay, and then I will write here break, so we're gonna break out of our while loop. Then let's add the rest of the options. So for example, if I want to add a user, I can do the following. I can do else if action equal to add user. So if we write add user, if the length of the command is smaller than 4, then we're going to show the usage to our user, or we'll show how you can add user. And lower than 4 means that we have less than 4 words written, right? So if we have 4 words written, the first one will be our username, right? So we'll assign this to username. Then the read permissions, okay, we're gonna assign to this variable to read permissions, and then we'll assign the rest to the write permissions. Okay, so once that's done, we're going to create a new user in our cloud with the username provided and with the read and the write permissions that the user specified. And we're also going to print what has been added. Okay, so similarly, we can add the rest of the commands. So, for example, if we want to upload a file, okay, we're going to assign, so we're going to write upload, and the next word that the user writes, we're going to assign it to the file name, okay, and the third word that the user writes is going to be the content of that file. After that, in the cloud, we're going to run the upload file function. We're going to pass the file name, the content, and the user under which we're going to add this file, and then print that so we can see if the action was successful. The same thing we're going to do with download. We're going to write download, then the file that we want to download, and then we're going to run the download file function from our cloud. There we're going to pass the file name and the current user. So if the file name matches a file from our dictionary, then we will be able to see the contents of that file. Finally, we can do here the list option that will simply run the list files function with the current user, and we'll be able to see all the files under that user. And then we'll be able also to switch users by specifying the switch user command and specifying the new username which we want to add. So if the command that we type is a wrong command, then we will display that this command is unknown. Okay, so finally our cloud is ready. I'm just going to add one line to run the main function in order to execute the cloud, and now we're able to use it. Okay, so I'll simply click the play button, then run main, and as you can see now we're in our cloud and we can interact with it. If I write a command that is completely wrong, you can see that we're seeing a message unknown command. Now, because already I'm registered as admin, okay, you can see that here is written admin, and now let's try to use some of our commands. So first of all, if I select upload, okay, then I'm going to see the usage for the upload command. So let's do upload. So file name, I want it to be hi.txt, for example, and then the content, hi, my name is Martin. Okay, so this will be taken as 3 parameters, right? So firstly upload is the command, the hi.txt is the name of the file, and the hi, my name is Martin, so everything else is going to be the content inside this file. So if I click enter, you can see that the file hi.txt is uploaded successfully, which comes right from the upload file function. So we activated this sentence right here. You can even see my spelling mistake is also spelled in the same way here. Okay, next let's do list, and once we do that, you can see that we have one file that is called hi.txt that we just uploaded. Okay, now let's try to also download the file. So if we do download hi.txt, you can see that we were able to download the file hi.txt that has the following content. So this means that we successfully uploaded, downloaded, and were able to list the files on our cloud while doing this in a completely secure way by adding encryption to our cloud infrastructure. So that was everything for today, guys. Thanks for watching, and I will see you next time.